Okay, in this podcast we're going to talk about double replacement reactions. They are probably the most difficult because they're a little bit complex, several steps involved, so they just require a lot more practice. Alright, so here's several examples of double replacement reactions. Potassium chloride plus silver nitrate gives me silver chloride and potassium nitrate. In here, what we are doing, in all cases, these are ionic compounds. We have a positive and a negative ion, and a positive and a negative ion, and they are swapping partners. Just like when you go on your double date and you have two of you in the front seat and two of you in the back seat, and you decide, okay, don't like each other, we're going to swap, and you swap partners. Now, when you swap partners here, you always have to have a positive and a negative, right? You can't have two negative ions, or you can't have two positive ions, so that's the only requirement. Okay, so not all double replacements will occur. So the challenge with double replacements is determining whether or not they're going to react. Many of them don't react. So these are reactions that occur in solution. So you have a solution of one ionic compound, a solution of another ionic compound, and sometimes nothing happens. They all just float around. So what you need to determine is whether or not a new product is made. Okay? You've got to have a new product made, otherwise it's an NR, no reaction, right? So the three products that are possible that you need to be able to recognize is a precipitate, a solid, and I'll show you how to figure that out, a gas, or water. Okay. So let's talk about the steps. So the first thing is use the general form of reaction to determine which ions come together. Okay. You determine if the reaction is going to occur, and then you figure out the products, charges of the ions, and write the subscripts, and then balance. Okay. In order to decide whether or not something's going to a reaction will occur, one of the things we got to look at is whether or not we make a precipitate. So a precipitate is a solid that's formed in a chemical reaction. So if we have soluble ions, soluble compounds that are formed, they are not a precipitate. So what we need to have is something insoluble. A solid is something that's insoluble in water. Okay, so we got to be able to read this table and figure out what we're making and whether or not it's solid or not. So again, if it's insoluble, that means it will form a solid or a precipitate. Okay. So here we have silver nitrate and zinc chloride. So this is the positive ion, this is the negative, positive, and negative. So the silver and the zinc are going to swap places. So I'm going to end up with zinc nitrate. Okay. Now zinc is a +2, nitrate's a -1, so I need 2 zincs. And I'm going to end up with the silver with the chloride. Okay. Silver's a +1, chlorine's a -1, so I'm going to end up with silver chloride, AgCl. Okay, so, and all of these are aqueous. So what I need to do is look up what's going to happen with zinc nitrate. So let's take a look at the solubility table. And what I see here is that all nitrates, with no exception, are going to be soluble. Okay? So this is going to be aqueous. It's going to be in solution still. No indication of a product. And then I have silver chloride. So let's look for silver chloride. Alright, so let me see. Chlorides. Chlorides are soluble unless the exceptions include silver. So if I have a chloride with silver, it will be insoluble. So, I have a solid formed, and therefore the reaction will occur. And because the reaction will occur, I need to finish and balance this. Because I have 2 chlorines here, I'm going to need 2 here, 2 silvers, so we need 2 silvers here, and it looks like everything balances, so there's a voila. Alright, let's do another one. Here I have HNO3, which is nitric acid, and iron 3 hydroxide, right? So an acid's going to work just like a ionic compound. This is a plus ion and a minus, a plus and a minus. So this is actually a base. This is an acid-base reaction, which is a form, a type of double replacement. Okay, so let's take a look at what's going to happen. I'm going to end up with H and OH, which we also know is water, but it's helpful to think of water in chemical reactions as HOH, because that's how they're going to separate. This will be a plus ion, this will be a negative ion. Okay, so we're going to end up with water plus the iron is going to end up with the nitrate. And because this is a plus 3, right, this is a minus 1, so this must be a plus 3 ion, I'm going to assume I have a plus 3 over here. So I'm going to have an iron 3 nitrate. Okay? So one of the products we said indicates we've got a chemical reaction occurring is water. Alright? If we have water formed, the reaction will go. So now all we need to do is balance. I've got 3 nitrates here. I'm going to need 3 here. I've got 3 hydroxides and 3 H's, so I'm going to end up with 3 waters. And I should be good, so voila. Okay, let's take a look at one more. Here I have calcium carbonate and hydrochloric acid. Again, hydrochloric acid is going to split like that. The calcium will end up with the chlorine. This is a plus 2, minus 1, so I need CaCl2. The hydrogen is going to end up with the carbonate, HCO3. This is a minus 2, plus 1, so I need 2 of these. Now, let's take a look. Calcium chlorides are going to be soluble. Okay, so this is going to be aqueous. But what we said was this is one of those acids that's going to produce a gas. So because of that, this is going to be a reaction. It's going to go to completion. Okay, so I've got 2 chlorine and 2 hydrogens, so I need to do that, and it's going to do that.